Okay, so Node.js, just kind of, you can see here's a graph of the module counts on GitHub, and you can see Node.js it's in the blue, and it's, increasing way faster than all the other kind of modules, PHP and Java and Go. And the reason why is because it's very easy to import into other code. To do an npm install something, it's a lot easier than whenever I'm trying to get new libraries on the microcontroller. Node.js, have y'all heard of that? It's kind of new. It was created, Node.js is a JavaScript compiler from Chrome, so browsers are going to be able to compile JavaScript, and Node is the JavaScript portion of the browser. And before, you would think about JavaScript in the client, but so before I would always use HTML and some JavaScript, sending some HTTP requests to PHP, and the PHP would be linked to some MySQL server. And that's generally, if you go out, that's probably the larger percentage of our designs out right now. But really, I've replaced, I've been using PHP for probably 15 years, more than 15. That was my first language. I started when I was 12 with PHP and MySQL. So I have I like it. I like that, using that language. I have, but it's clear to me that Node.js on the back end, it seems like it's just easier to whip up a site really quick. It's a little bit different how you have to think about when you write the code. So like Python or C, it's a much more linear process. So as you're going through the code, you kind of think, this happens, and then this happens, and this happens in these loops. Kind of like if you're used to like Arduino kind of programming, you kind of like go in these loops. Whereas JavaScript it's more asynchronous. So each function, you still have these orders, but you can't necessarily rely on the execution of one coming before another. And so you have to use callbacks or promises to kind of handle that. But so in Python, for example, if you're writing, it's an effort, to do multi-threading or to use multiple, you have to think about these kind of asynchronous processes. You're aware of it, where in JavaScript, you're almost not aware of it. It just happens for you. And that can be frustrating when you're first trying to learn it. But, the typical design, so I use Git, for all, that's where, I store all this code. The code you see here will be on Git. So limit library imports, that's what I was saying. So you don't want to attach yourself to too many, other libraries, because then it makes you not as able to move to different projects. Here's kind of things I think about when I'm coding. Modularity, you want to extend it. Complexity, so how big are your functions, like how many indentions, how many recursion loops do you use? Robustness, readability. I care more about readability now, because I don't comment code that well, and so when it's readable, like JavaScript is a very readable code, it makes it a lot easier. So not trying to prove that you're smart, but actually it helps you in the future, and you like yourself for doing that. The environment that you're programming in, I try to use Linux because I can usually get help if I can't understand something or something's not working. You can find someone in the community that can help you, and that's a huge benefit, and it's free. I try not to couple. I made like a double pendulum thing, but the graphic's not showing. But when I think about code, I think about a lot of times I'm sure you all have seen this before, the double pendulum. And basically, if you can have two simple systems, like a pendulum is a pretty simple, second order differential equation that you can model. But if you attach, a pendulum on the end of another pendulum, to actually, fully understand the angle and the position of the pendulum after, some, very few number of time steps, it becomes chaotic. It becomes impossible to know that completely. And so you don't want to couple your code together. You want to have independent modules that kind of can behave on their own. Otherwise, it leads to unpredictability. So this is kind of how this is what I, like whenever I made these slides a year and a half ago, it may have changed the orientation, but generally I'll have like a relay server, and that will run WebSockets. So WebSockets is a protocol that is on top of your regular HTTP, and it's good because, you know, I just want to set up a lot of these sensors that are up. You know, they're up for several months, so I don't need to, you know, create a whole new request every time I want to send data from one device to another. So, you know, if my camera needs to talk to the room sensor, then, you know, it just creates a connection once. That's what WebSockets does, and then you can just send and emit messages, and it kind of lends itself to asynchronous, you know, thought process. In our current project, we're using, you know, sockets within the program. So you can have sockets within the program and then use sockets, you know, in between entire devices. And you can wrap that in SSL as well. So these are kind of the components that I use: Angular, jQuery, JS. JS-MPEG helps me decode the MPEG stream in the browser. So it's a JavaScript-based MPEG decoder. And so Angular is a popular, have people heard of Angular? Angular is pretty cool these days, seems like. I think it's kind of cool. But so Angular is kind of MVC framework is how they describe it. You have your view, which is your HTML. And inside the view, like I can make, you know, loops inside HTML. You know, loops through an array, but you fill that array and you control that array with the controller. And there's people way better than me. Angular, I feel kind of like with MATLAB, where, you know, I understand like a small thing, you know, I'm just doing addition on it, and it's so much bigger than what I know. But this is how I use it, and it seems. But you should make a lot of like services and directives and all kinds of stuff. But, you know, just this helps me connect all my stuff together. And it's big enough that I'm not afraid that it's going to, like, you know, be gone or, you know, go out of style next month. So, you know, that's why I stick with it. We actually we just hired 2 Angular programmers. Okay, so that's the relay. So yeah, that's what I was saying earlier. Like I move everything from PHP and MySQL and Apache, and you can turn that into Node.js and MongoDB. And then that way you kind of keep it JavaScript all the way through. It helps the coding style. And JavaScript's a very easy, you know, syntactically it's easy. I guess, you know, it can be conceptually hard if you're not used to asynchronous programming, but I don't think it's that bad. So website, run devices, socket for messages, okay, and then on top of that I'll use SHA-512 for my tokens. So this is like an old, I've made tons of them. Every once in a while I'll put a version on it and then increase the version number. But, you know, this is one of the room sensors. The new one's a little bit smaller, so that's good, right? Smaller, it's kind of better. And it's interesting because, like, when I first started the design, you know, I haven't seen these slides in a year. You know, there was a lot of analog components on there. Like, you know, that's kind of how I thought. I mean, my background's in electrical engineering. Maybe I should go through my background. So I went to school at OSU, got a degree in electrical engineering, got a job at a labs, at Sandia National Labs in Albuquerque, New Mexico. And then they paid for my master's at Rice in Houston, and I did electromagnetics and photonics, which is like the you know, the light spectrum. Electromagnetics is the long wavelengths, and the photonics is the shorter wavelengths. But and then, you know, I didn't really like working there, like the day-to-day job. You know, there's things that, you know, a lot of times you do things that sound good when you can talk to people about them. You know, I worked in the nuclear weapon department, on lasers. That it sounds really cool. But then you say, like, I'm, writing code in a language that I don't like, and you don't really understand the whole system. And, a lot of people, and so I don't know, I just got kind of fed up with that. And so I was like, okay, I want to think about like biology, I want to transfer human consciousness onto a different media. That'd be pretty cool. And so I went to medical school, but then I realized medicine's not. So a few years into that, I was like, okay, I could probably do more for medicine and health outside of being a doctor, because it just you kind of eats at you. And I have a lot of devices that I think could help take medicine back into our hands, where we're storing the data ourselves and releasing it as a community, instead of it being in hospitals locked in servers and proprietary software. So I started a software company, Pi-Fi. That's where you're seeing this logos and everything. And we've been doing home automation and security mainly. But now we're doing some auto in-dash entertainment kind of stuff, which has been a lot of fun. And whenever I started Pi-Fi a few years ago, I had, the first kind of shitty website I put up had 3 sections on it. I mean, didn't have much to them, but I just knew that these 3 sections, that home automation, car, it was Pi Car, and Pi Health. So those kind of 3 sections. So I haven't done much in the health sector, but I would like to make more devices in that realm. And that's where the ESP32 can probably come into hand, that we'll talk about here shortly. Okay, so JavaScript on microcontrollers, I wouldn't do it, but I like JavaScript, but I wouldn't put it on a microcontroller. It's just too much overhead. But they're doing it, and that's cool. Maybe at some point that'll create something. But there's enough overhead trying to run these on ARM and low-level microprocessors to try to do it on a microcontroller is maybe a little too much. So machine learning with this stuff, so I think a lot, obviously that's like the craze, right? Everyone's thinking about machine learning, and so I kind of think, what problems exist in home automation? How can I measure my anxiety levels and have all these variables that this huge multivariable nonlinear differential equation, and instead of me trying to sit and think about how you just tell this machine that is 1,000 Einsteins to do this, and 1,000 simulated years in one day, focusing on making, my, anxiety levels drop, or help me sleep more, increase my sleep patterns, make sure I hit, go past REM sleep, and, or make the best grilled cheese sandwich that I've ever had. That'd be a good use for 1,000 Einsteins. So that's kind of interesting, but it's a kind of an idea thing, people talk about it a lot, but, it's kind of harder to execute. How I think about it, where I want to do on my microcontroller is kind of have multiple layers of machine learning. So on the microcontroller, you can have kind of a lower level interpretation of the sensors, but and then layer that on top of, so you can have that immediate responsive interaction if you need it, but then have that higher kind of cortex in the server to do more complicated linear algebra. But I don't know why I put molecular storage, because I read a paper at the time about DNA, storing information on DNA, and it was half a gram of DNA can store over 1,000 terabytes of information. I'm like, holy, that sounds cool. Half a gram, that's like an SD card over 1,000 terabytes on DNA. And it's because of the structure, it's a 3-dimensional structure, so you can store a lot more information on a 3-dimensional structure than a 2D surface. So here's some links. I'll put, I guess we'll probably have a place to put all these, and these are all open, so you can look at them. Okay, so here's more of the hardware stuff. So this is for the thinking about the light sensor, the Liger, which I actually call it a room sensor. Yeah, I guess it has a lot of names, but let's say you wanted to have it under $30 at a quantity of 100, replace a standard light switch, and with an indoor environment. So, exploring potential solutions. So a microphone, and then, okay, so this is, when I started out, like I said, I had a lot of, analog components, but it's interesting, like how I got it so small was you switch those out for digital. It seems obvious, right? But at first, you think about in the analog world, you read all these articles and you think about photodiodes and how they change, and it's really cool. And then you realize, oh, I can just do this in code, and that's pretty cool whenever you actually have to get it done. And so, but it's a background. Sometimes you save money, like, because you're reducing the number of external components. So, like, for example, on this, so they have a video of me. Do they have a video of me? They can see this? Okay, cool, maybe. I don't know. So you probably can't, but this sensor right here is a pyroelectric, PIR, motion detector sensor, right? So, initially, you get an external module. You'd probably go on, some Arduino SR, blah, blah, blah module that they cranked out 100,000 of them, right? Or you can think about, a PIR, you can do it in, there's a lot of different external, components to a PIR sensor. This has 0 external components. So even though, it's $20, which is ridiculous, I save on board space, right? I don't have to buy external components, and I can implement it all in code, right? So, I can pop in a new one. I think this is Exilitus or some, so I forget what model this is, but I think Lawrence may know what model. He told me, he's like, oh, I just used that. And I thought I was cool. But, the cool thing about this is you can swap it out for another model and you don't have to change the external components, right? So if there's a lot of external filtering, that's specific to that sensor, well, you've kind of now, narrowed your design down because you change that sensor, now you have to rethink and re-understand a bunch of stuff. Whereas if it's a digital one, you can just, find a library to import and then you're good. So same with the speaker. So like at first I thought, oh, well, I'll just use an op amp, right? That's what you use, an audio quality op amp. But then, now you're using up, you may not have the resolution on your pins like to do that. And you have a lot of external circuitry to filter the sound and handle noise and to think. But now I just use an audio codec with I2S, right? So I2S is digital, and I don't have to think about it as much. I don't have to think about, and I can just pop in a new codec if I don't like this one, or they go out of business or whatever. And so my designs aren't, centered around some kind of proprietary circuit. And so that's kind of how I got it. So this is, we got temperature and humidity. I use a lot of I2C, so following that kind of the same, along the same vein, using I2C helps it, reduce component size and pin count, because you can attach several devices to an I2C bus. So, the photodiode is I2C. Initially, the photodiode, I thought, okay, I'm going to make it an analog, right? And then I have an analog digital converter on this, and I can just measure that, right? And that seems easy, right? But then you get noise and calibration stuff. You're just like, okay, well, no, I2C seems easier. So I'm using, so these are this is an IR transmitter and IR receiver. And so, this is the first model that I went with a surface mount IR receiver, and saves on board space a little bit. Okay, so yeah, so let me kind of describe. So I described some of the components. I know this is kind of AC. I'm doing nonlinear, talking kind of a little bit nonlinear here, but this is just how I think. This sensor actually goes into a light socket. So you pull out a standard light, and then you can pop this sensor, and it fits with the same bolts, and then you put the cover on. This is an LED light. It's directional, so I just have 2. The ESP32 has 9 touch-enabled pins on it, so it can handle touch. And then I'm just using this I got from Alibaba, like 1,000 pieces of these rubber, it's kind of like on a MIDI controller on a piano. And it's directional, so I can go left, right, up, down. And that way I kind of, it's a very low component count because I'm just pulling out a trace to a pad. There's no, pull-up resistors or anything like that I have to implement. So it's directional. So you just put this in a light switch, and then you can adjust the light so it connects to a relay, a solid state relay, so you can turn on and off the light with this. But then when you hit next, you can control the rest of the devices on the open automation. So thermostat, and you can watch the LED change color, adjust the thermostat, hit it next, the volume on, I'm just running a little Linux program, a Node.js program to control the volume on any Linux device. So, and then speaker and microphone. And the ESP32 also has Bluetooth, which I tested, but it's not very stable. I haven't, that's where I'm at. Just like most of us, we have more ideas than time. And so, to implement Bluetooth and all these features, that's what I want. But, I'm pressed for time. So yeah, this goes into a standard light switch. It has, the motion detection, it does a lot of autonomous features, has a nice speaker, so you can communicate. One of my goals is to allow it, because I remember whenever I was growing up, we had an intercom system, and you don't really see those a lot, the intercom systems, and why can't you have some kind of communication between these devices using WebSockets through the network in the house. Okay, also another kind of feature that I added was, so mainly there's two kind of systems in a light switch. You have a 2-wire and a 3-wire system. And a 2-wire system is a very simple, you have where the current passes through, you just, tie 2 wires together, and that turns on the light through the switch. But a 3-wire system, you have 2 wires for that you can power the device off of, and then another wire that goes on, another line wire that goes to the light. So that way the device can always stay on. So most of these devices, these smart devices, require a 3-wire system because 2 of the wires have to power the device. But with this, I did a lithium battery. With the help of someone here in Star Space, I'm going to switch to supercapacitors. But if you can use a 2-wire system, because if you have a battery, it's just like a phone. If you switch off the wire, then it just goes into battery mode. And since it's connected to those 2 wires, it can know, oh, hey, my battery's low. I need to connect these back and charge up. Also, I thought about, okay, well, it can charge up probably at a current so small that it wouldn't illuminate the light, and so you can almost keep it powered. But I'm actually probably going to switch to supercapacitors because it can handle those kinds of fluctuations. I don't have to worry about longevity. I don't have to worry about lithium in my wall with the insulation. That seems kind of dangerous. So I think I'm going to go to supercapacitors. So all right, let me show you my schematic in the KiCad portion. I call it KiCad. Everyone calls it. It's because I have never heard someone physically say it, and every time I talk to someone, people say KiCad and all kinds of. I like KiCad, so I'm gonna go with that. So KiCad is a circuit design program, and it's free, which is nice, and it runs on Linux, which is also nice, and you can make. This is what I do. This is how I get my circuit boards made. So like this is the Liger. So I kind of, when I first started making circuit designs on here a few years ago, the schematics were very, I try to fit everything on one schematic, so it was very jumbled. I use divider lines and try to make it look good, but now I kind of do it in this Node.js kind of thing that's invaded my mind, where it's kind of more modular. So I have switches, and then I can import these switches into another. I just use different sheets. How do I go back up? I forget how to go up a level. Oh, here. No, that's how you create a new level. I mean, it'd be kind of ridiculous to restart it, but you do what you gotta do. I'm missing a bunch of symbols, and okay, so these are all modules, and I I wish I had time to go through the history of these circuits and like show you like how like the PIR sensor, like that was the biggest, probably like 30% of the board area was that PIR sensor, and now it's just literally this. So, right, a couple resistors. I mean, it's nothing. I mean, it used to be 30% of the design. So, but I try to keep it modular in how I lay out the schematics. Okay, now so after you do the schematic, then you go over to the board layout area, and this is where you can run the traces. Unfortunately, you can't do the auto trace stuff. Doesn't work. I wish I could just click a button, but I guess machine learning hasn't got there yet. And then you have a 3D view. If it comes up, there it is. So I'm on version 0.6, I guess. And this is where the ESP32 goes. The wonderful thing about an ESP32 is that it's $2. That's why it's awesome. So you get a lot kind of for not very much. It's like, why not just throw it in there and make it work? So yeah, KiCad's awesome. I can't say enough good things about it. It's ran by CERN. They seem pretty legit. So I wish I had like a demo of all these things I'm talking about, so you actually believe me. But let me show you. So I'm gonna lose a mouse. Okay. So one of the libraries that I'm using, because since a lot of my designs revolve around kind of one of the core communication protocol I use is WebSockets, and it really just helps with getting behind firewalls, getting behind routers. I don't have to do any kind of port forwarding. I mean, imagine if you had to port forward 20 devices in your home. That would be horrible, right? And then your router resets or something happens and you get new IPs you have to run. No, that's not a good plan. But WebSockets allows me, so I don't have to do port forwarding at all. This guy on GitHub did a WebSocket project. I'll show you up here. I'll try to make these things bigger when it's relevant. It's called lib WebSockets. Oops, that's not what I want. And it's a C-based WebSocket program code that you can run on an ESP. It wasn't built for an ESP. It was just built for low power, low speed microprocessors and kind of a Linux environment. But it was ported over to the ESP32, so that saves time for me. And but like a lot of things, like when you try to import or use someone else's library, now I feel almost too attached to that library where I'm looking at it way too much. Like, why am I thinking about that library, right? Why I don't want that. But that being said, he has like the like good factory settings, so it'll broadcast as a Wi-Fi access point, and you can connect to it. Let me show you what I'm talking about. So this is just a open source library you can find it on GitHub here. WarmCat is the owner of the repository. And we're going to use make all flash monitor. And on my device, I have two switches, like a reboot and a program. You can't see it, but you can imagine it. And I just hold down program as I hit reboot. Oh, I hit it twice. That was the problem. Okay, so there we go. So now it's uploading. That's always nice when you see it uploading, the the binary. Especially because I just had to, right before I came here, I had to strip this and the ground wasn't connected. Okay, so we're gonna restart it. And then, and now it's gonna broadcast an access point. And I should be able to see it on my laptop here. So ESP43, blah, blah, blah. So you connect to it, and you can see, oh, it's connected. You can, wait, I need to make that bigger. How's that? Yeah, okay, that's better. And then make that one bigger. So I don't have an IP yet. That's not good. Oh, because it's still connecting. Oh, come on now. Oh, there we go. Okay, so we got an IP. The cool thing, he just recently pushed an update that's pretty cool. It allows me to, it automatically comes with SSL, so you don't have to like generate an SSL certificate or anything like that. It generates it as you compile it. So now when I go to the IP address, I actually have to go to HTTPS. Oh wait, no, you want to go to 1 because it's the router. Hopefully it works. It's connecting. It's not the best web server, but that's not what I use it for. This is just to give it your password to your Wi-Fi. So let's see here. See what Wi-Fi's are available. I probably should, let me broadcast my own. Okay, here Wi-Fi is the router I'm broadcasting. Store in that slot. Put it in there. See, and stuff's not showing up. This isn't my library. And let me connect to that on here. Probably should have done that from the beginning. Set up. It's my first time. All right. Okay. Everything's connected. Let's see. I don't know what IP address. I could use Nmap, but Nmap takes a long time, even though I really like it. What am I? Let's see. I'm 4.3. Just get that going. Actually, this is like the only thing I use my phone for is this app called Fing. It scans the network. Oh, but I can't, I'm broadcasting network, so I can't connect to itself. That's, okay, whatever. All right, Nmap. Oh, don't freeze, please. I'm using a Microsoft Surface, and I put Ubuntu on it, and it's actually surprisingly good. Like I didn't have to get drivers for the touchscreen or the video drivers or anything like that, but it does seem a little buggy. The Wi-Fi is a little buggy, even though right here it was connecting up just fine. It looks like I have frozen. Okay. So I mean, really what I'm going to show you is, like a broadcaster router, you connect to it, it connects to your router. And then inside that, I upload my own firmware, so it runs on a different space in the memory. And then I just boot from that from then on. Hopefully, maybe next time I can get a better demo up where you're seeing lights blink and things happen. But, life isn't always rainbows and butterflies, and I like peanut butter and jelly. It'd be nice if there was a lot more peanut butter and jelly in my life. But, okay, well, if you have any, like, I know there's probably a lot of questions, but, but you don't even know how to ask them. But, what's up?
Okay, so I kind of missed out on the part about supercapacitors. That's how you're powering it?
So the main power would go through the line just by, you get a 5-volt, regulator. But the supercapacitors help whenever, see, if you have a 2-wire system, right? So I haven't seen many people do a 2-wire system out there. And if you have a 2-wire system, that's like cutting off the branch you're sitting on, right? So if to flick off that switch and turn off that light, it's going to turn off the room sensor. And so the supercapacitors just help charge it quickly, and so whenever the light's off, it can be powered off the supercapacitors. And that seems maybe a safer method than using lithium, and it can handle more cycles, right? So you wouldn't have to be getting in there and replacing that. So, that's why you need a community to bounce ideas off of. People that go around and they keep their ideas secret, like usually they're not very good, right? Bouncing that and getting that feedback and putting your ego down that you've been building on that. That's important.
So, what are you using to grab the power off the AC?
So I just have a regulator. I just got off Alibaba. They have a whole bunch of them. I was looking at, no, but I can show you. I have a lab. Anyone wants to come hang out, I have a lab in my house, and I show you all my scopes and my regulators and all the boards I've been working on. I actually have a regulator. It's not an AC/DC regulator. It's a regulator for a solar panel. So it goes from 7 volts up to 40 volts, and it has an ESP32 on it. So when it's outside, I can see the light level. I can see how much power is going to my devices. These are cameras. These are cameras I set up for clients in remote areas where they need to watch construction sites. And so I just put an ESP. I have like 3 Wi-Fi devices on this little unit, just because it allows me to have my fingers in many different things. If something goes wrong, if I need to reset the camera, I can log in through not log in, I can reset it through the ESP32 through the web GUI. So it kind of allows for redundancy. But, yeah.